I think it was page 34 was the, so I'm just going to do that, and hopefully you've had enough practice on equations. There will be at least one on during the quiz tomorrow. Okay. All right, so 34. What if you have something like this? Page 34. You should recognize that this is an equation. I'm asking you to solve for n. You can guess if you want to see, right? Is this maybe perhaps, but I need to see the work if you want to get marks here. Okay? So what this means is when you see NPR, you got to think of the formula for NPR, right? You take whatever is over here, you put it on top with a factorial, and then in the denominator you go n minus r factorial, right? So you turn this into an expression like that, essentially. Okay? So we will do that. So going by this model, I'm just going to tell you that sometimes these get really ugly. You might have something like n plus 1 or n plus 2 here. It doesn't matter. Just treat this as a chunk, and this chunk goes up top. You're not going to have one of those on the test because I just won't, but maybe on an AC down the road. So n factorial like that, and then it's n minus r. R happens to be 2. Right? R happens to be 2. Like whatever that chunk is, right, you subtract it. It's basically top minus bottom. That's what this is saying. So we do that. Right? N minus r right here. Make sure there's a factorial, and that's supposed to be equal to 20. So this is one extra step that we needed to take to get it to an equation that we recognize.
Excuse the interruption. Mr. Esselmont, please contact the office. Mr. Esselmont, contact the office.
And you need to tell me for both top and bottom what makes that 0. So you would want n greater than or equal to 0 for the top, and for the bottom, n would have to be greater than or equal to positive 2. And this is the overall restriction. That's the one that goes overall. Okay, this is the one that we're going to abide by. Then you need to ask yourself, which one of these expressions is the bigger one? The top is bigger. N is bigger than n minus 2. Okay, so we go n, then it's n minus 1, and then it's n minus 2. And you see that there's an n minus 2 factorial, so you stop there, even though this could keep going. I will stop there because it will conveniently cancel out here. Okay, so that would be your next step. And then you distribute this out. You get n times n is n squared. You get negative n, and that is equal to 20 here. We'll bring the 20 over, subtracting. So n squared minus n minus 20 is equal to 0. And I will factor here. So n is your variable. Negative here. Negative times negative is positive. So you know that these numbers will have opposite signs. And then I'm thinking, what multiplies to 20? 1 and 20? It works, it multiplies, but it would get you 19 if you subtract them, right? So that's out the window. 4 and 5? 4 and 5 works, right? But where do you put them? That's important. I will put the 5 here and the 4 there. And the reason being is, right, if you multiply these to the first smiley face, you get negative 5n. You would get it if you FOILed it out. And if you do the smiley face by the ends there, you get plus 4n. And if you add that up, you get the negative 1n, which is what we're after. And that's just a little check to see that you're doing this right. Maybe after a while you don't need the smiley faces anymore, because you'll know, right? I just need to make sure when I add these, the 5 and the 4, I get negative 1. Okay, that is your goal. So you've got two solutions here. For this bracket, n is equal to 5 will be a solution, because then this turns into 0, turning everything to 0, which will equal the right side. Solution number 2, out of this bracket, we get negative 4. And if you go back to your restriction, we told ourselves that n has to be greater than or equal to 2 for this to work. So this is the only solution that works. This one does not work. And then you do a quick check. I would suggest that you go back to the original, right here in fact, and then you just go 5p2 is supposed to be 20. You plug this in, but you should also remember if it's 5 pick 2, remember you're filling in 2 slots in a sense when we did the fundamental counting principle, and that's 20 is equal to 20, and you're good to go. This is just for you to verify that you indeed did this right. Okay. So if you want more, on Google Classroom I took a picture of the textbook, and there are more there. There's like 4 more for you to try if you want more than what you have in this booklet. Keep in mind that if you are able to cancel in such a way that there's only n left, no n squared, you would not be factoring. You would just literally solve for n, like bring all the numbers to one side, leave n completely isolated. Okay. Question. I can turn this one into a different question just like that. Okay, watch this. If I did this to you, whoa, what's a 2 doing there? I would try to get rid of that if I could. Yeah, you might have to leave it there, but I see that if I divide both sides by 2, right, this will cancel out, so you end up with np2 is equal to 10. And then you I'm not even sure if this is solvable, to be honest. Like I just made this one up for you too. I don't think it works. 4 pick 2, that'd be 4 times 3. That'd be 12. 3 pick 2, that'd be 6. So this one doesn't have a solution. So just so you know, I'm just showing you this step right here, the fact that this is there. You know what would work if we just make this 40? Make this 40, and if you divide by 2, you get 20. You're essentially back to the original that you had just up top. That way you're not wondering like, what? I'm going to try this one, and it doesn't work, right? Technically, there is such a thing. You would just say it doesn't work. It's not solvable, but we won't do that to you. Like you will be able to get a value for n. Okay, that's not part of the curriculum where we try to figure out what doesn't work. Okay, so this is it for equations. Any questions? Go look at Google Classroom if you want more practice. The answers are there too on the second page of that scanned document.